All right, let's look at this example. So, according to a Gallup poll, 60% of American adults prefer saving over spending. X is the number of American adults out of a sample of 50 who prefer saving to spending. What's the probability distribution of X? So, since we're working with binomial distribution, we're going to say binomial. All right, but we can sort of do a check. All right, so my first check is that, is there just two options, spending or not spending? So it's like, yes, only two options. Are the events independent? So let's have two options. And you go, if I choose people randomly, yeah, they're probably independent, right? They wouldn't be independent if you didn't choose them randomly. Like if you chose people just from one neighborhood, you could have, the trends could be similar from the people. But if you're doing like a true random sample, then one person's spending habits shouldn't really influence another person's. And we have this probability that we're assuming it's constant, and the probability of success. So success is that Americans prefer savings. So the success is defined as saving. All right. So it's a binomial with a probability of success of 0.60 and a sample size n equals 50. So you often write it like this, sometimes without the p and the n, but it you're given all the relevant numbers that will help you find probabilities. All right? So in part B, we're going to find some probabilities. So part I says find the probability that 25 adults in the sample prefer saving over spending. So we're doing x equals 25. All right. Number 2, we're finding the probability that at most 20. So probability that x is less than or equal to 20. And part 3, we're looking at the probability that more than 30 prefer saving. So probability that x is more than 30. All right, so again, our x, the variable x is out of that sample of 50. How many prefer saving over spending? So x could take the values of 0, 1, 2, all the way to 50. All right, so if you pick a sample, you could find that none of them like spending, all the way up to 50. Okay, so we're going to use our StatCrunch to do this calculation. So we want to fill in the p and the n. Okay, so let's have this from the last example. Let me actually start again so you can kind of see if this is the only example. So we're doing stat calculators binomial. Gives you this. You're going to put in n, which is 50, p, which is 0.6. And here is where you choose the x value. So first one was x equals 25. So you go x, bring it up a bit. Oops. Come on, work with me. X equals 25. Compute. Alright, so that red bar is like x is 25, and it tells you it's 0.0405. Alright, so 0.0405. Alright, probability that x is less than or equal to 20, this will add up the probabilities of x is 0 through 20. Okay, so we're going to go back here and change this to x is less than or equal to 20. Compute. And it's, you can see the red bars here, there was added up. It's tiny, 0.0034. So 0.0034. And finally, the probability that x is bigger than 30. So we're going to go x is bigger than 30. Alright, so it's adding up all these red bars. So 31, 32, all the way to 50. So 0.4465. Alright, good. So that's how you find binomial probabilities of all kinds with the StatCrunch calculator. Alright, so using the formula to calculate the mean and the standard deviation of that variable. Okay, so there are formulas for a binomial distribution, mean and standard deviation. The mean, mu, is given by n times p, so kind of the number of people in the sample times the success rate. It kind of makes sense. Like if I have 50 people that I'm looking at, and the probability that each of them is going, is going to prefer saving is 60%, then or 0.6, you do 50 times 0.6, and this is a 30. Okay, so on average, if you take different samples, different random samples, on average, out of a group of 50, 30 of them will prefer savings over spending. All right, this is also called the expected value, so the mean and the expected value. Mean the same thing, okay? All right, let's look at, for standard deviation, actually, let me just scroll down. So standard deviation, sigma, this is square root of NPQ. That's the formula that's given. All right, so N is how many? P is the success, which is 0.60. Q is 1 minus P. Okay, so that was going to be 0.4. Okay, so P and Q always add up to 1. Okay, so we're going to do this. We have square root, or 50 times 0.6 times 0.4. Take the square root of that, we get about 3.5. That's the standard deviation. Alrighty. Okay, and again, if I pull StatCrunch, like 30 is the mean. You can see it in this distribution, that's symmetric, it's at the center. And standard deviation of 3.5 kind of, gives you the spread.